Unit 3-3.2, which is on graphs. Graph is a visual representation. In other words, it's a picture of a formula or of a function. A visual representation. The big thing about graphs, if we want a picture of the information, it has to be accurate. If your graph is not drawn to scale, if you are just not even using a ruler, just roughly drawing something, you are wasting everyone's time. It's not telling you anything. So it has to be accurate. Let's look at this equation. This is a function, right? For every number I choose for x, I will only get one value for y. But what's also true, I can choose any value for x, any real number, and each time there will be a y value. So if I took all these pairs, the x and the matching y, and I plotted them on the xy axis or on the Cartesian plane, which is what we call it, it will give me a visual representation of this function. Right, easy way to do it is use the table method, because we're only going to ask you to draw straight line graphs, and then a table method always works. By table method, I mean you draw a little table, you choose a number of x values, and you work out their matching y's. So I like to choose a number of negative x's, then include 0, and then a number of positive x's. Then to find the y's, I'm going to do one of them as an example. If I take this and I substitute the -2 in there, can you see that becomes 1 plus 6, which is 7. Then I put its matching y there. And you keep doing this with all of them. And there you have x's and their matching y's. Now, to draw it, you have to use a ruler. You cannot say, oh, I don't have a ruler. It is part of your tools that you need. You have to have a ruler. I can't use a ruler on the tablet, so I'm doing my best to draw a straight line. This is a number line, and it is the number line of x values. And then vertical number line is the number line of y values. Then again, you use your ruler and you measure equal sizes here. Generally, if you measure 1 centimeter each, that is good. So again, do not guess. Measure properly. Then you can choose each step. Is it going to be 1 unit? Is it going to be 10 units? Whatever. I'm going to make the x-axis 1 unit each. So that goes up to 5. Remember, 0 is where they intersect. So these are the -1s, -2, etc. And then on the y-axis, we go up like that. And again, using a ruler. However, your y-axis scale does not have to be the same as your x-axis scale. So I'm going to make each step 2 units on my y. So you are allowed to do that, but for the whole of the y-axis then, each step must be 2 units. Now, if we look at our first one here, when x is -2, y is 7. So 7 would be there. So you start at 0. You go 2 in the negative direction. Then you go up to opposite 7. again, make sure it's accurate, otherwise you won't get a straight line for a graph. So -1 goes opposite 4, 0 goes opposite 1, 1 goes opposite -2, 2 goes to there, should be -5. And now again, because I don't have a ruler, mine is not so nice, but it should make a perfect straight line. You can put arrows on the ends to say it goes on forever. It's also good to write the equation of the line there. That way, if you now draw another one, then you know which line is which. So what I'm going to do now is I'm going to say on the same axis, draw another line. Draw y equals 2x minus 4. So you do the same, you set up a table. I'm going to just go without the table. Our space is a little short. And I only used -1, 0, and 1. So -1 was opposite -6. 0 was -4. 1 was -2. So there goes this graph. And this is y equals 2x minus 4. So remember again, the whole line, it's the set of all the x's and y's that satisfy that equation. For every x, you get a different y. Now, if we want to find the intersection, this point, called the intersection, it's the one set of coordinates that makes both of my equations true at the same time. And again, if you drew your graph accurately, then you can read it off. The x value is 1 and the y value is -2. So that is the intersection of the two lines.